Okay, here we go. Lesson 1-7, which is inverse relations and functions. Now, finding the inverse of a function is actually pretty easy. The whole main idea is you just flip-flop the x and the y in the function, and then you resolve it for y. It's not too bad. But what can be tricky is trying to figure out if an inverse actually exists. And we have studied before, I'm just going to scratch on here the graph of, this will be y equals x squared, which is, as you know from class, one of my favorite graphs. Y equals x squared is definitely a function. Why? Because it passes vertical line test. But we have this new test to see if an inverse exists. It's called the horizontal line test. What the horizontal line test does is it goes a little deeper than what the vertical line test does. The horizontal line test tells not only if there's one x for every y, but it also tells if there's one y for every x. And if it fails the vertical or the horizontal line test, like the graph y equals x squared would, then there is no inverse function to that. But something like, let's get the x cubed graph up here. X cubed would pass the horizontal line test, which means that it is a one-to-one function, as is stated in your notes, I believe on the very first page. And since it passes the horizontal line test, this has an inverse, and we can find it. Okay, we're going to start on the third page of this packet. It's actually page 39, because this is really where the most important stuff of the lesson is, I believe. Now, like I said before, finding an inverse really isn't too bad. Let's start with number one. Number one says this: f of x equals 2x minus 4. The first thing I'm going to do is change f of x to y, and then recopy just like that. So we have y equals 2x minus 4. Now, the big step is this. Take the y, put it where the x is. Take the x, put it where the y is. So now we have x equals 2y minus 4. And now what we're going to do is resolve this equation for y. We're going to add 4 to both sides. And then we have x plus 4 equals 2y. Finally, divide by 2. And we end up with y equals x plus 4 over 2. And then to finish this off, we're going to use the inverse function notation, which is right here, the f to the negative 1. So finally, we would say this: f to the negative 1, or the inverse function of x, is equal to, and then what we figured out over here, x plus 4 over 2. Okay, next, let's look at number 2. Now, sometimes it helps to graph these things and see what they look like. Now, here is my grapher, and as you can see, that graph is just the x squared graph with a scale factor of 1 inside the parentheses and a scale factor of 2 on the outside. And what I mean by that is that graph was shifted up 1 and to the right 1. I guess scale factor wasn't the best way to say it. It was more of a slide. So this is still the graph of y equals x squared. And as you can see, it would not pass the horizontal line test. So all we have to say is, how about D and E for does not exist? Okay, moving on. Number 3, which is 5 over x minus 2. And I have the graph of that one waiting right here. And that is just the inverse function graph. Now you'll notice as it runs out towards negative infinity and positive infinity, it gets closer and closer and closer to the x-axis, but it won't ever catch it or cross it. So this would pass the horizontal line test, and we can find an inverse for this. Now the trickiest part about this is getting that denominator out of there. So remember, first step, let's switch the x's and the y's. So we'll have x equals 5 over y minus 2. Now I'm going to multiply both sides by y minus 2 to get this denominator out of there. So now what I'm looking at is y minus 2 times x equals 5. Now what I'm allowed to do is divide both sides by x. So divide by x, divide by x. And now I'm looking at y minus 2 equals 5 over x. And then the last step, undo this minus 2 with a plus 2. So finally, I have y equals 5 over x plus 2. And then we'll use inverse function notation. F to the negative 1 of x equals 5 over x plus 2. Now the last one we'll do together, number 4, is just the x cubed graph. But as you remember from our A, B, C, D shifts and scales that we can do to our graphs, this is just the x cubed shifted up or slid up 4 units. So this will pass the horizontal line test, so we can find an inverse of this. Step 1, get rid of the f of x, which I didn't do over here. I just skipped straight to switching the x's and the y's. Get rid of the f of x. Let's call this y equals x cubed plus 4. Now let's switch them. X equals y cubed plus 4. And then let's go after solving for y. Subtract 4, subtract 4. So x minus 4 equals y to the third. And we're going to use the cube root function to get rid of the cube here. So take the cube root of both sides. Cube root of x minus 4 equals y. And then we can flip it around and use our inverse function notation. F to the negative 1 of x equals the cube root of x minus 4. Hopefully this introduces inverse functions and gives you a little bit of confidence to move forward with the rest of this packet. The front page, try the ones on the front page, and try the ones on the very, very back page as well. And then you can tackle the word problems on page 2, and we will go over this next time we have class.